Hello, everybody, and welcome to our webinar on intelligent networking and data communications challenges in battery storage and how to solve them with HMS Networks. I'm Andy Colthorpe, editor of Energy Storage News here at Solar Media, and I'll be moderating today as we hear from two speakers at HMS working on the company's ICSOT brand. The global energy transition happening around us today is, of course, based on renewable energy and other low carbon technologies, and batteries are very much a part of that, a critical part. But in the 3Ds of the energy transition, digitalized sits alongside decentralized and decarbonized, and of course we can add the fourth D, democratized. Digital technologies are what enable the smart grid of the future. And in a battery storage system, the software, the EMS and BMS, allow the BESS to charge and deliver its stored energy in the ways that offer the maximum benefit for the longest lifetime. I don't remember very much from my high school mathematics classes, but I do remember a teacher saying to my class in an algebra lesson that a chain is only as strong as its weakest link. We all intuitively know this to be true in any organization in team sports. We can see right now many industries are at the mercy of global shipping delays and cost increases. We can see how high-tech industries can't get the chips they need to make their products. Within the BESS itself, the same thing applies to data communication and networking. You can collect as much data as you need, but if your system's setup doesn't accommodate for the right ways to transmit that data, you turn your smart system into a dumb one. Similarly, with the industry becoming increasingly global, understanding that it's not just languages that are different in different markets means being wise to using the right protocols to communicate between your battery energy storage system and the local network. Well, of course, today's speakers can tell you about all of this in much greater detail than I can. Freddie Dahlberg is product manager for Smart Grid at HMS Networks, based in Sweden. And Matt Shustak is HMS Networks business development manager, joining us from the US. As always, interaction with you, our audience, is a really important part of any webinar. And we will be holding a short Q&A section at the end of our speakers' presentations. HMS Networks also welcomes further offline discussion on any specific points you're interested in, so please do feel free to reach out to them. And finally, slides from today's presentation will be sent to all attendees. You will also be able to view an on-demand recording of the session on the Energy Storage News website in a few days' time. So with that, I'd like to hand you over to our speakers, Freddie and Matt.
Thank you, Andy. And first of all, thank you everyone for your time investment with us today. My name is Matt Shustak, and I'm responsible for overall business development functions for the ICSOT brand here in North and South America. Primarily, my role is really the interface between customers in the Americas and the various technology centers within HMS. And two of those examples are really our ICSOT product development teams in Ravensburg, Germany, and for example, our software solutions center in Manchester, New Hampshire, which handles various software development projects on behalf of our customers. Before we get started, just an overarching comment, I guess, to kind of set the stage for today. One thing has become abundantly clear to us through our engagements in battery energy storage over recent years, and that is that simply not all BESS are created equal. Instead, we've learned really that each company and each system has really its own unique set of challenges, especially from a networking and communication standpoint. And there simply is no one product or solution that's going to apply to everyone. So for today, instead of a product pitch, we're really going to try to outline and drill into some of the common challenges or common design trends, I should say, we're seeing in the industry, some of the challenges that companies are facing, and really try to illustrate how HMS should be considered a credible and trustworthy resource to partner with going forward. So that being said, we have quite a bit to cover in a short amount of time. So let's take a look at the agenda. So first, we're going to review some of these, let's say, common threads or overall design goals, as I mentioned, and the resulting challenges that companies are facing. For the purpose of this presentation, we split these into two general categories. The first being network design, and the second is data collection and grid integration. Of course, we're going to dive deeper into some of the specific challenges within each of these categories. After that, we're going to zoom out for maybe some perspective on a term that we're using repeatedly here, which is our flexible technology toolbox. It's a bit of a mouthful, but it'll make more sense as we go along. But the overall premise here is that we really offer a suite of hardware and software solutions that can be applied in different ways to help address and solve complex communications challenges inside of energy storage systems. Then, of course, we're going to open things up for a little bit of Q&A. So let's get started. Let's look at some of these, what we're calling design goals that we're seeing inside of BESS. So the first one perhaps is a bit obvious, but as companies iterate on their designs, one overarching goal is to continuously drive down the cost of ownership of their systems, both for themselves and their customers. This isn't only to remain competitive in the industry, but obviously also to support the required growth rates for total energy storage capacity going forward. So some of the challenges, of course, there's a lot of different facets to cost reduction, but one topic that can become quite tricky, especially on larger grid scale BESS systems, is related to the battery and BMS communications. Another parallel or related topic, some companies are investigating ways of utilizing what we call second life battery packs in their systems. And if you're not already familiar, there are some specific technical issues that need to be addressed from a communications perspective there. Safety and system reliability is naturally a top priority for BESS companies, and as a result, significant engineering investments are made to prevent any sort of unexpected incident causing a catastrophic type of situation. So in much the same vein, taking special care to ensure your communications hardware is properly protected is something that should not be overlooked. Next, most BESS companies are continuously looking to achieve greater, what we call system design flexibility, meaning becoming less reliant on any given supplier. This ranges from the heart of the system, the battery modules themselves, to auxiliary systems like cooling or fire detection. But achieving this kind of flexibility can greatly complicate electrical and software engineering when attempting to maintain and manage support for all of the various communications protocols that are involved with these systems. And lastly, companies are always looking for ways to leverage the enormous amounts of data generated by their systems. There are plenty of applications for AI or ML, but two that come to mind are simply continuous efficiency optimization efforts or advanced functionalities like predictive maintenance. But some companies inside of BESS find it a bit cost prohibitive, specifically not only accessing and collecting, but also perhaps more importantly, interpreting the relevant data from specific parts of their system, for example, at the battery level. And then again, a parallel related topic, depending on a number of factors, interfacing your BESS with external systems like the grid or a SCADA can be cumbersome, to put it simply. So let's dive in a little bit deeper, starting with what we're calling network design. So as we all know, the heart of any BESS is the battery technology. Most battery manufacturers today utilize CAN bus for battery-related communications, but exactly how they apply it does tend to differ. For example, some BMS architectures inherently require CAN to be implemented across a very large physical area, which can be challenging due to network length versus bit rate limitations with CAN. Further, if you're familiar with CAN, you know that it is based on a standard line topology, but this can be strategically modified, you could say, using correct hardware, or a combination of hardware, in order to achieve what we might call hybrid technologies like tree or star. Luckily, HMS has extensive experience with designing and supporting CAN-based systems, as well as numerous flexible solutions available to help BESS companies cost optimize their BMS topology. We'll look at some of these a little bit later on, of course. Actually, just a quick note, you'll notice a theme here, which is the colored dots that we're using. These are really meant to indicate a specific type of communications function inside of the system. This will make more sense, I think, as we go along here. So if anyone here has attempted to integrate second life, what we call second life batteries, into their energy storage system, you're probably already familiar with this specific challenge, but the issue arises because second life batteries typically are received having been programmed with a CAN identifier already, and many times, especially if it's from the same manufacturer, they're using the same identifier. But since CAN identifiers need to be unique within a network, this can be problematic when you try to, of course, combine them together in an energy storage application. So again, luckily, there are some ways to overcome this issue on the system side, specifically using special CAN topology tools. Safety and system reliability, again, naturally top priority for every BESS company. And as a result, significant engineering investments are made in this area. So again, in the same vein, ensuring that your battery and BMS CAN bus specifically is properly protected and isolated should not be overlooked, because doing so, I should say, because properly protecting and properly isolating ensures that these mission critical systems are not only protected against damage, but also protected from external influences like EMI, which can create some pretty significant headaches down the road, either at commissioning or farther down the road, of course. Why is EMI specifically a concern? A number of issues, but specifically, CAN bus is very reliable and robust, but a key requirement for that is having a stable reference potential, both for the CAN high and CAN low. Since grounding conditions specifically are rarely perfect and will inevitably vary both site to site and system to system, galvanically isolating the CAN bus is a trusted and proven way to sort of neutralize that potential EMI influence. We'll take a look at some of the ways our solutions incorporate galvanic isolation when we look at the toolbox a little bit later. So another topic, most BESS designers are aiming to be more, you could say, agnostic and essentially less dependent on any one equipment or technology provider. This certainly applies, again, not only to batteries, but to what we're calling ancillary systems here, such as air conditioning and fire detection. Now, some ancillary equipment OEMs choose to offer proprietary communications hardware with their equipment, which of course can become pretty costly, especially at scale. So what we've been seeing as a result, both for simplicity, but also just cost reduction, Oftentimes, BESS engineers will opt for simple digital I/O interfacing to these types of systems instead of more data-rich communications options. Now, again, the good news here is that HMS offers solutions that are built specifically for simplifying and standardizing both the hardware and the software interface to such ancillary systems. And essentially what I mean by this is it is absolutely possible to achieve both greater design flexibility and standardization at the same time, really. And now I think we're going to kick it over to Freddie.
Yes, okay. Hello, everyone. Thank you for joining us. And as mentioned before, I'm Freddie Dahlberg, Product Manager, Energy Communication at HMS Networks. I will speak a bit about two interesting and perhaps more nebulous topics: data collection strategies and integration with external systems such as SCADA, grid, and perhaps some others. So let's start with cloud data collection. Battery energy storage systems typically use CAN-based communication, and as CAN is not an Ethernet-based protocol, it cannot be directly connected to the cloud. This specific communication challenge, shown here as purple and blue dot, can be solved by adding a CAN to industrial IoT gateway, converting the data to the relevant cloud protocol like MQTT or OPC UA. However, there are a few key aspects to consider before sending all of your CAN traffic to the cloud. There will be a lot of CAN traffic, so you will want to filter data to only send what is required for your controlling, logging, and alarms. Make sure that you format the data in the correct way to suit the cloud system. Poor data input will in most cases give you incorrect or misleading reports. Think about how your system is designed, or ask your supplier, can you work with CAN database files, or would you like to use a software like MATLAB Simulink? If your BESS systems are designed differently and you use different modules, you also need a solution that can be flexible, not having to start over from scratch with each system. What happens if cloud connectivity goes down? Do you need local logging to not miss out on that valuable data? In some cases, local decision-making is required not only to process and format data, but with edge intelligence, decisions can be made without relying on cloud connectivity and potential response time. Depending on your specific challenge, you might need a multi-purpose solution. Like if you most likely have several CAN buses, you might need both bridging and gateway to the cloud at the same time. So what about smart grid or SCADA connectivity? When integrating battery energy storage systems to collaborate with other systems like power grid SCADA, renewable energy sources, heavy industry, or mobility, integrating communication is key to achieve high efficiency and return on investment. On a higher level, for external communication from the BMS or EMS, battery energy storage systems typically use Modbus-based communication. CAN is mainly used inside and with the battery modules. Power grid SCADA typically uses energy protocols like DMP, IEC 61850, or IEC 6870. Heavy industries typically use industrial protocols like Profinet, Profibus, or Ethernet IP. Renewable and mobility typically uses industrial protocols, Modbus, and/or Open Charge Point protocol. However, there are a few key aspects to think about in this case too. Security. When controlling functionality is used by a SCADA system, security becomes critical, so you should consider TLS encryption, and/or VPN. Also, things like user access rights and signed firmware updates are very important. Multi-network connectivity, like interconnection of a BESS with industrial energy and cloud protocols, you will need several protocols at the same time. SCADA demand, what kind of data is wanted and/or required, and which protocol is preferred. This to enable control and data visualization from the SCADA system. Data pre-processing, for example, Modbus protocol doesn't support decimal point, so values needs to be scaled before they are sent. Also, Modbus doesn't support timestamping, which may be required by the SCADA system. In some cases, local decision-making is required not only to process and format the data, but with edge intelligence, decisions can be made without relying on cloud connectivity and potential response time. And/or if arguments can be used to group alarms into minor or major for easy implementation into the SCADA or cloud. We've seen several examples of requirements where both SCADA and cloud are involved. Here it's important to think about security and multi-network connectivity. So maybe you will want to have network separation and support for both Modbus, MQTT, and IEC61850 at the same time, or any other combination that we've talked about. So let's summarize. So far, we haven't really referenced any products or solutions. However, we have referenced the so-called technology toolbox. So let's try to unpack what we mean by this term. And when you partner with us, you will get full access to this toolbox. And we're looking for these long-term partnerships, so we will support you along the way. To borrow a phrase from earlier, not all BESS are created equal. Each has its own set of requirements and challenges. And the intent with this slide is to illustrate both the size and versatility of the HMS offering as it applies to BESS. First, let's quickly review the solutions for CAN-related challenges. Starting from the top left corner, we show some of our CAN topology components. The colored dots indicate the range of functionality included in that specific device. So in the top right, we've listed what each color means. Note that the connector lives in its own category. This is a very versatile device, which can serve multiple functions in a CAN system, including bridging, local logging, with support for MATLAB Simulink, and much more. At the bottom, you see some of our tools in the area of testing and commissioning, which we haven't even covered in this presentation. Starting from the left, you have USB to CAN, which is an easy tool to plug into your laptop, and together with our CAN analyzer software, the traffic can be analyzed. CANcheck is a handheld device that can check the physical cabling. Moving further to the right, we have AC interfaces, which makes it easy to integrate proprietary AC communication. Then we have our X gateway that can gateway between 250 different protocols depending on model. Finally, of course, we have our secure smart grid gateway that can offer connectivity to smart grid, SCADA, industrial IoT protocols at the same time as being able to perform logic functions and scale values. Also, with support for TLS and OpenVPN, signed firmware updates, to name a few security features. Lastly, in the top right, our Flexi Cozy is used for remote access and remote data. We support a variety of cloud providers. We also offer our own SCADA system, i4 SCADA, for visualization and control. To sum it all up, with our flexible toolbox, you will find the solution to the unique challenges with your BESS communication, no matter if it's relating to isolation, bridging, extending, gateway, energy communication, cloud, industrial IoT. We're here to help you. So finally, we would like to encourage you to contact us to review your specific communication initiatives and partner up with us. For additional information, please be sure to visit hms-networks.com/BESS. Thank you, everyone. That was all from my side. Now let's open up for questions.
Fantastic. Thank you so much, Freddie and Matt. As we said at the beginning, there's a lot to unpack in a fairly short space of time. As mentioned, the guys are very happy to continue talking about this stuff with you guys offline as well. So do feel free to get in touch and follow up once you get your pack sent out to you after the event. Just before we go into questions from the audience, and we do have quite a few questions, quite a few good questions, let's say, from the audience. I'd just like to exercise my editorial privilege a little bit and get involved. A couple of quick questions of my own, really, I guess. So, guys, you referenced quite a few different challenges in that presentation, but can you perhaps share some sort of tangible examples of where you've helped customers to address challenges using the toolbox? And I understand that some of this might be commercially sensitive and you might not want to name customers as such, but yeah, some sort of idea you can give us on there. Matt, do you want to maybe take that one?
I was actually going to volunteer to take it anyway. Thanks, Andy. I think that's a totally valid question. Very good question. A specific story comes to mind that actually came up during the height of COVID travel restrictions. So when we talk about partnering with a customer and really trying to systematically break down their challenges and provide solutions, I think it's a good example. I guess long story short, it's hard to capture quickly, but the company was deploying some relatively new system designs. These were very large grid scale BESS systems utilizing CAN bus, and technicians were having troubles on site during commissioning with random sort of communication dropouts at the BMS level, and it was very difficult for them to pinpoint exactly what was happening and, of course, how they're going to resolve it, especially on such a massive system. So again, long and short, we were able to work with them 100% digitally, spanning multiple continents, actually. A lot of different time zones, a lot of flexibility required on both parts. And what we did was really we utilized the toolbox. Actually, I guess if we try to illustrate, oops, sorry. We really started with in the bottom left, the CAN testing and diagnostic tools. So simply put, using USB to CAN dongle combined with the CAN analyzer software allowed us to get at least some insights as to why were we seeing these random dropouts. Of course, we noticed a pretty significant amount of essentially active error frames on the bus. And so we knew we had to look a little bit deeper to try to understand where the error frames coming from. So we utilized the CAN check and some other software tools to look at the physical layer, essentially on the bus. And that kind of brought us to a pretty clear indication that a combination of some cabling and wiring issues were at play, in addition to basically exceeding the maximum length that the bit rate could accommodate. So long and short, we were able to provide essentially a path to a solution here, combining some cabling fixes, cabling and wiring fixes, I should say, and also applying some of our topology tools, specifically the CAN bridge, which allows companies to essentially extend the network physically while still maintaining the high bit rate that they needed.
Right. So you're able to bring together kind of a holistic kind of approach to troubleshooting all of those problems, really, I guess. And it's I guess COVID meant that you kind of had to do a lot of it remotely, but it also sort of proves that you can do it remotely, really, I guess.
It's a good point. I think in hindsight, it was almost good that it happened during COVID because it forced us to act quickly, and we leveraged digital tools, remote technology, and I think we came to a solution faster than we would have if we had to physically show up on site and all that kind of stuff. Faster and cheaper. And I think more importantly, we were able to resolve the issues on site that they could then scale up and roll into future design revisions. So that was really, when you talk about holistic solution, it was fix what's wrong right now and give us a solution for going forward that we can trust.
Okay, cool. So yeah,
and I mean, I should mention we do have a maybe a more extensive version of the story posted on the case study section on the BESS website.
Right, yeah, I did see actually some quite some really interesting stuff on there as well. Like I noticed there's work you've done with a Second Life battery company called Connected Energy from the UK, repurposing electric vehicle batteries to be used for stationary grid storage, and that's something you referred to. And yes, as you say, I've personally found those case studies really interesting on the HMS Networks site. So do urge our viewers to take a look there. So yeah, one more quick one from me then. Freddie, you mentioned that there's several different energy protocols, and also known as grid integration protocols or grid connectivity protocols. I mean, is there a big difference between countries and regions, and what sort of challenges can that present?
Yeah, so DMP is mainly used in US, UK, Australia, and 6870 is mainly used in Europe. 61850 is global, and even though we mainly see growth for 61850, both 6870 and DMP are still relevant, and this creates the need to, depending on where your system is being commissioned, you might need to support several of these to be able to integrate to the existing infrastructure. And of course, we can help you with that.
Okay, sure. So, I mean, I'd expect that there's a much more detailed answer that, if we weren't limited by time and space, then yeah, no doubt.
There's a lot of history involved in the DMP, how it evolved, and the 6870, how that evolved. But we see a lot of movement into 61850 now. But equipment, you don't want to replace all the equipment at once, and therefore there's the need for bridging between old and new, and there's also all sorts of challenges within bridging between old and new, and integrating your BESS system into a system like that.
Right. Okay. So yeah, so we're scratching the surface of some fascinating topics here, but yeah, I think it's time to let the audience do some of the asking now. And as I say, we've had lots of questions in, far more than we can possibly answer in this time. But yeah, so just to start off, really. And sorry, you can all see on your screens there that there is a call to action. I believe the term for it is that you can find out more through the clicking the button there on your screen. But yeah, so audience member Salvador Casente asks, could you address whether safety can be enhanced through improved data monitoring and data collection?
So I guess data, you will need data to improve safety. I don't think I have a really good example here, but to know that something is beginning to go wrong with your system, you need data for that. So it could be anything from temperature sensors to voltage levels or anything that can be analyzed to improve safety.
Okay, fair answer. Yeah, so audience member Bill Gray asks, what interfaces are you using for BMS, battery management system communications, given that traditional RJ45s designed for the office environment are not suitable for use in switches, routers and controllers in more harsh ESS environments?
Yeah, it's a good question, Bill. I would say, I guess in our experience, specifically for BMS communications, of course, we're mostly talking about CAN, and CAN, there's a number of different physical connection options available. RJ45 is one, sub V9 is one that's a little bit better, but M12 is also nicely IP rated, you could say. If you, yeah, I guess the point is, if you need that connection, let's say outdoors in a harsh environment, most of the time, I think what we see is the interface itself is typically housed in an enclosure anyway, and so not nearly as sensitive from an IP rating standpoint for the interfaces themselves. If that makes sense.
Okay, yeah, it does very much make sense. So there's a question here from Inaki Muniz, who asks, in the case of grid-connected and co-located energy storage systems co-located with solar PV, will each storage station cabinet have some kind of a communication box to connect to the SCADA system? And I'm guessing this is probably a question of design and strategy, but just wondering if what your opinions are, I guess, from you guys onto what the right strategies would be for that sort of question.
I guess it mainly depends on scale, like how big is it, and how many do you have, and as Matt referenced before, that not all BESS are created equal. There's several ways you could solve this, and when it comes to our solutions, being in between there, we can also do both depending on if there's one cabinet or if there's several cabinets. It's it's a design question, I guess. Sure.
And referring, I think, probably to the brief allusion to the case study that you gave, Matt, Oliver Crichton, thanks for your question, Oliver, asks, do you need someone on site to plug in the USB to CAN adapter, or is there a way to connect remotely and use the CAN analyzer software?
So I think that's an excellent question. The way I would answer it is, within the toolbox, we do have a number of, let's say, tools that you could combine to achieve more of a fully remote connection, kind of as you described. I guess it really depends on, I guess basically in our case, we had the people on site, available for the physical connection. So we just went that route instead of, let's say, overcomplicating. But from a design aspect, could you incorporate that kind of functionality into a design of a BESS? Absolutely. And again, the tools are certainly there, even within HMS, for sure.
Okay, so that really does go back to your old point of, and we've said this plenty of times today, but not all BESS are created equal.
I guess it's really interesting question, Oliver. Yeah, there absolutely is. There are multiple ways to, let's say, achieve a remote connection. So yeah.
Yeah, I mean, if I may add into that, Matt, I think that the CAN analyzer software that we have works with all our CAN components. So if you utilize, I mean, for sure, you need someone to connect it in the first place. But any device, not only the USB, can work with the CAN analyzer, and therefore, if you implement CAN@net, we haven't gone into detail about what that is, but if you do that, then you could potentially remotely connect to that one and access the raw CAN data and analyze it.
Thanks for adding that. Yeah, that was a good point to make. As long as you have the physical connection there in the system somewhere, the software works with all of them, if that makes sense.
Yeah.
Okay. And a slightly different type of question from Brian Parker, who asks, Brian is assuming that your primary client is a battery energy storage system OEM. Are you currently selling your products to battery energy storage system OEMs in the USA? And I guess really the broader question is, who are your primary clients really, I suppose? Is it a spectrum of stakeholders, or is it one particular sort of subset?
Totally valid question. Short answer is yes. I would say that is probably our primary, let's say, customer base today. But because of, you could say, the versatility and the flexibility of the toolbox, it's now spreading into some of the battery developers themselves, sometimes even the end user, of the BESS, sometimes companies who are more or less consulting to help customers deploy BESS. So I would say it started with the BESS integration OEMs, and it's certainly branching out from there.
Okay. I mean, yeah, we see, obviously from our point of view, we see the industry kind of diversifying and all sorts of different players coming into it almost on a daily basis at the moment. So we'll see if the answer to that is kind of different in, 2-3 years time, really, I suppose. But for the time being, that's sort of where you guys are kind of targeting your efforts, really, I guess. Okay. It's a question that, to my slightly less technically minded brain, sounds really interesting, but I'll let you guys be the judge of that. So Leon Ghosh asks, are Modbus protocols from different battery manufacturers? Leon gives the examples of major players like Samsung, LG, and CATL, etc. Are they completely differently structured, or do they have some kind of common ground? I don't know which of you guys would like to take that, if that's a decent question.
Yeah, I guess I can try to answer that. So they do have the common ground of being the same sort of communication type, but the way Modbus works is that it's registers. So you read the registers from the BESS, or you write to the registers, which is sort of like reading or writing to a database, you could say. And the difference between different vendors would be how they have structured this. So they might have different data available, and it might also be scaled differently. As I mentioned before in the presentation, there is no decimal point in Modbus, which means that a lot of the time when you, for example, want to send a voltage value, you have to scale it to get the resolution you want on the data. So then some supplier might take it times 1,000, someone takes it times 100, and this can then differ. But of course, with our toolbox, you can connect to this, and you can scale it, and you can create sort of templates to handle different vendors within the same device.
Okay. So yeah, we've got questions still coming in, but I think unfortunately we are kind of running out of time now. So we'll just do one more quick question to round off. I mean, unless there's anything else in the list of questions you guys can see that you really want to answer, but I just thought we should mention this because it's something we keep hearing about, not just in energy storage but elsewhere. It's cybersecurity. And Keith Stevenson, thanks for your question, Keith, asks if BESS qualifies as critical infrastructure, and if so, how is cybersecurity considered in the network design? Now, I think whether it qualifies as critical infrastructure is perhaps more a question for regulators and governments and so on. But yeah, if you're assuming that battery energy storage systems are a really important piece of the the energy security puzzle, really, I suppose, how is security considered in the network design, and sort of what sort of strategies around that would you guys imagine that people should think about, really, I suppose?
Yeah. Yeah, I mean, I agree with you. If it qualifies as critical infrastructure, it depends on the size and the local governments and so on. But cybersecurity is of course very important. No matter the size, it is important. And I think mainly it's considered in different ways depending on what kind of data you are allowing to be outside, so to speak. So if you only send data for logging purposes or analyzing purposes, the security implications aren't as great as if you are also controlling it. Because if the worst thing that will happen if you are just collecting data from your BESS is that you don't get the data. But if you also are able to control it, then potentially a lot of things could happen. But there's countermeasures around that. As I mentioned before, utilizing encryption, making sure that the devices that are connected are in a certain level of cybersecurity. But there's also this way of when you have a gateway in between, it creates a sort of media break. So the gateway will only forward information it understands. So that can give you an additional layer of security, so to speak. I don't know if
Okay.
that.
No,
I guess it's a very big topic, so we can talk about that for a long time. But I hope it's a good start.
Absolutely, absolutely. And I think everyone watching this can probably tell that I've learned quite a lot just from working with these guys for a pretty short time, and I expect that it would be fascinating to continue on. But unfortunately, we are at the end of our allotted time for today. I've really enjoyed this. I hope everyone else has. As a call to action on your screen once again, if you want to find out more, just click the button in front of you. For all of that, though, I think probably it's time to wrap up. HMS Networks, as I say, would love to carry on this discussion with you offline. If you asked a question, I believe they will be reaching out to you to try and help you solve that and get that question answered. And yeah, with all of that, just want to say thank you very, very much to Matt for joining us in the US, Freddie for joining us in Europe. And I'm no problem. And once again, I'm Andy Colthorpe with Energy Storage News. Thank you so much for joining us, and we hope to see you again soon.
See you next time.
Thank you so much. Thank you.
Cheers.